Hello, my name is Renaldi, and I'm going to be giving my talk automating smart analytics with Power BI and Azure Machine Learning. I hope you're enjoying your time at the conference so far, as I'm sure that all the talks here have been very insightful so far. And I have also a big thank you to give to the organizers for making this conference happen, as I'm sure that without all the organizers' hard work, this conference would not have been a thing. And it's really a great thing to be able to see this conference happen. So thank you as well to all the sponsors who have sponsored the conference. And to start off with, I'm going to talk a bit about myself. I am Renaldi Gondosubroto, as I've introduced. I am a founder and developer advocate and CEO at Grow Studio. I am a Microsoft certified Azure Solutions Architect expert and Microsoft certified DevOps engineer expert. My personal field of interest is within security practices, architecting solutions, data analytics, and other cloud-related best practices. On the side, I run meetups, the occasional hackathon, and VR tech enthusiast. And for meetups, I mainly run meetups within Australia, since I'm based in Melbourne in Australia. And I mainly run meetups based on topics that are related to new technology or in regards to gathering more developer advocates and such. So in regards to the agenda, today I'm going to be talking firstly regarding about the context of what I'm going to be basing my case study on, which is going to be regarding CRM data. And initially, to start this off, I'm going to be talking a bit about collecting and processing data with edge devices. I'm going to afterwards be talking about the architecture we will be looking at. After that, I'll be moving on to talking about iterative development and monitoring. Afterwards, going into working as a team on ML models, machine learning models. And finally, I'm going to be talking about what we got out of it, essentially, for our team, and essentially what you can get out of it as well. So firstly, I'd like to use this chart as kind of an inspiration on getting into using Azure if you haven't yet. So the Azure, over the past quarters, the Azure market share has increased, as you can see in this chart, for example, according to Catalyst. We have seen over the last quarters that there has been an increase in regards to usage of Azure cloud services in comparison with other particular cloud providers. And especially during the case of COVID, we have seen also a rise in cloud computing compared to previous years. And this has been a continuing trend, essentially, that we have been continuing to monitor and continuing to be able to utilize and continue to see. And I believe that this trend will essentially continue to follow alongside the whole development of the cloud and the whole cloud computing market. So now I'm going to go into talk about collecting and processing data with edge devices, and this particularly in regards to collecting environmental and CRM data, which is going to be what the context is about. And I'm going to be talking about it in a few slides later. So essentially, this first step would be to provision devices and resources as evidenced by basically the whole architecture that we are trying to establish. We need to be able to establish strategically where we want to plan the devices and where to establish them, and essentially how we plan to be able to best utilize them to be able to generate the data that we need. Afterwards, we go into planning and processing and visualizing the necessary information. We want to be able to utilize the data that we've collected from the devices in order to best put the data out and essentially be able to provide a better view of how we want to be able to visualize information as necessary. And This is going to be based on the analytics that we provide. And afterwards, we'll be going into adapting and transforming culture, as this is where the crucial part begins. Because the crucial part begins not only within provisioning the device and resources, or within processing and visualizing the information, but in the end, how we can transform our culture accordingly, as this is basically what we need to be able to establish when we try to transform our culture and essentially continue on to adapt and accordingly towards the needs that our company needs according to the data models. Because adapting to data machine learning models and utilizing that, if we haven't yet, it's not an easy thing if we haven't started yet. And essentially, we would like to be able to start putting out the models as we need to, and essentially adapt accordingly, according to the insights that we receive from our models, and plan accordingly for the next steps. So this is an example of a traditional visualization of data in Power BI. Essentially, we've always operated previously with raw data, and this is just an example of how we've operated with raw data. Essentially, our raw data always has consisted of straight from basically extracting data straight from raw, and essentially putting unlearned data. And as you can see, this is just an example of the particular raw data. Basically, it could be just an Excel sheet that we've just captured. And this is just an example of how we are able to process the data. We may get the data in this format, but at the same time, we may not be able to get much from it, can we? And because it's basically just raw data. I mean, sure, we can transform the data. And essentially, this is an example of how raw data cannot be compared to what we can generate from learned data, which I will demonstrate within the next few slides. And I'll talk more about this as a motivation within the next few slides. And this is a motivation for generating visualizations from data within machine learning models. Essentially, we want to be able to have smart analytics and hence decisions. This is evidenced by how we choose to adapt based on the data. And we want to be able to provide better presentations based on informed data that we are able to get through the analysis that we perform. And that's how we are able to obtain more insights. And we want to be able to show our clients and customers that we are able to act based on smart analytics. And that's why we want to be able to utilize this data from the visualization we obtain to be able to present better findings to our customers as well as stakeholders within the company, and be able to better generate better leads based on smarter data because of the machine learning that we've implemented. And as part of business intelligence, when we start developing models, there are a few questions that we still need to address first. Some of the questions that you may have to ask based on your data, and this always differs with everyone's particular own use case context, is you may ask something like, what types of data do you use to make informed business decisions? Do you use structured data, unstructured data, or do you use group data that is already based on data that you have obtained according to particular clusters? And it could be much other more than that as well. Are integrating cloud platforms with it? And this is essentially going to be a main topic for this talk, because after all, we're using Azure as the main cloud platform for integration with performing better data analytics. And afterwards, we'll be going. We may also ask about how we choose to compare results of deployments. This is also another thing that I will touch on in this session, as oftentimes within deployments, we will face different models, and finding the real the model that is optimal is always one of the hardest parts. We need to be able to have an iterative development and process of continually improving our models. And it's not a process that can be done in a short period of time. It may be something that has to be iteratively done, and it has to be something that we continue to do within a specified time period. And this is something that we have to iteratively develop and continue to develop until we receive an optimal model. And how do we analyze user activity? How are we able to generate models that are able to generate user activity that is correct, basically, and precise based on the findings that we have obtained? These are all questions that we've asked alongside the journey to building smarter analytics and models. And of course, we may have implementation plan and check as well. It's just an example of how you may, in particular, plan for such a plan. And essentially, we may have something like reviews specified to be able to generate particular sprints, for example, and put a review each time every sprint ends in an agile environment, for example. And in this case, particularly, we have requirements also designed. Essentially, we may collect requirements within a time period, and we may have experimentation slightly overlap requirements and occur alongside prototyping. And in this case, prototyping essentially is all about the designing of the new models. And this is in particular implementation plan when we want to be able to create new machine learning models, as well as implement these models as part of the features that we want to provide to our customers for better analytics. And this is an example of an integration plan. And in particular, after that, we may also have production development of the whole machine learning models itself, as well as what we want to be able to build alongside it. Perhaps we're also building our product alongside the implementation, or it could be implementation itself. And essentially, after that, we may bring it into deployment, because what we want to achieve through Azure and Power BI is that we want to be able to create an autonomous structure that we can continue running on. And essentially, if we are able to create this autonomy and leave it to its own devices, essentially running on its own, we're able to generate a better architecture and essentially be able to generate better insights because we don't have to get too hands-on with it. We'll continue the manual development, of course, but if we are able to let it run on its own, we're able to better utilize our time and utilize the resources more efficiently based on our current models and monitor more accordingly. And we'll be going into the case study now. So in this particular case study, as I mentioned before, we'll be talking about how we can generate better business decisions for services based on CRM data and data based on environmental monitoring, for example, and in particular, provide better insights compared to raw data. And just as a disclaimer as well, the data that will be used here is going to be sampled data that this was generated randomly for demonstration purposes, essentially. So it is not based on real data that is collected. So the architecture we'll be looking at for this particular case will be this particular architecture. So as we can see, and if you're not familiar with using Azure too much yet, I will introduce these services to you briefly. So we have data essentially, and we want to be able to be taken into Azure. So it'll be taken into event hubs for analytics. Essentially, we'll be taking it into event hubs because it is particularly the service that is used to take the data in and basically provide real-time ingestion, which is simple, trusted, and scalable. And afterwards, we can take it into data streams where it can be used for analytics. And we are able to basically directly put this into Power BI. but this is still the raw data. We want to be able to first get more machine learning insights first. And that's why we send it into blob storage, because usually, even if we do want to be used in Power BI, we would want to store the data first. And that's why we send it to blob storage, which is essentially an optimal storage for massive amounts of unstructured data. And we then send it into Databricks, which is essentially an Apache Spark-based analytics platform optimized for Azure, which is streamlined for workflow. It provides an interactive workplace, which allows us to later then send forth to machine learning. And this the core feature we'll be talking about as well. And in this particular case instance, I'll be talking about machine learning only from a high-level overview. I'll not be going into a tutorial-based kind of overview into this, as I know that resources are already available to look into for more in-depth tutorial view of how to utilize machine learning, the service. So because I want to focus more on how we're able to emphasize on this relationship and this connection between Power BI and machine learning and what we can get out of it from a high-level business perspective. And automating on the Azure Pipeline with PowerShell is one of the options to be able to automate this particular architecture. So essentially, this is an architecture of this is a script, for example, of being able to send data from the Azure that's received in the Azure Pipeline over to Power BI. And in this particular example, we can see that we are running a script that iterates over all the objects, essentially, that is within the database. And we then are able to connect it to Power BI through a particular script and essentially remove the old data and essentially update the old data with the new data that has come into the pipeline. So essentially, this is an example of how we're able to automate on the pipeline to be able to create an autonomous system to be able to send data from Azure to Power BI to be able to continually do this and generate better insights, and so that we can focus on creating models and have Azure continue to send this particular data accordingly. Selecting a machine learning model is always a particularly challenging thing for people who are not that familiar to machine learning. And I'm just mentioning 3 here. Azure has a lot of choices of machine learning models, but because this particular instance is more based on classification, these are some models that I picked out for it. So I'm going to be talking briefly about what each of these essentially are and how we're able to pick one particular model to use for our particular case instance. So in this particular case, we have a 2-bit class-based boosted decision tree, for example. Essentially, it's an ensemble learning method for a second tree to correct the errors in the first tree, and essentially third tree corrects errors in the first and second trees, and essentially so on. So this is going to be an easy method to get top performance, but it is a memory-intensive method. But at the same time, it is great for simple implementations, but it is not able to process very large data sets. For decision forest, it's also an ensemble learning method for classification. It provides better accuracy at coverage, but does not work well for simple models because of the dangers of overfitting. And there's also 2-class support vector machine, which is a learning model which requires labeled data. Essentially, analyze input data and recognize patterns in multidimensional feature space called the hyperplane. In this particular case instance, we'll be using the decision tree, as we'll be using a simple model for this case, which would have been overfitted if we did pick a 2-class decision forest for a tree instead. And when we design a machine learning model in Azure Machine Learning, we'll be encountering something like this, more or less. We'll be encountering something like having to design parts of the pipeline, essentially. For example, like in adding columns and cleaning missing data. And this will be elaborated more on the next slide. So this is what a particular architecture would look like when we lay it out. So there are quite a few components in this particular case. We can see that from the raw data, from the product engagement data that we put in, we have to first clean the missing data. And because in this example, we're basically replacing missing values with a 0. And that is one of the techniques that I'll be covering as well later for dealing with missing data that we may have based on the files that we have obtained based on the raw data. And essentially, we then also put churn labels as part of the data engagement as well. And we then add columns into it. And these columns will be based on the churn labels that are already put into. And after putting these labels, we will then split the data, essentially creating a training set and testing set, as we can see over there. And that's where the split happens. We start having one particular group for putting in the training model and basically another group as well, implementing the same thing. And we use a SPOT, as you can see over there. And in this particular case instance, we're able to see how the two different models will work out, essentially, and be able to contrast accordingly. And this particular case, SMOT, which is a synthetic minority oversampling technique, which is a statistical technique for increasing number of cases and data set in balanced way, enables us to also generate new instances from existing minority cases that we supply as input. And we're able to see some insights based on this data over the next few slides as we then train the model after we finish putting it into the different sets. We then score each model, and we then are able to evaluate each model. And in the evaluation point is where we are able to really see whether this model was effective or not and how it has improved in contrast with the particular models, or how it has worsened in contrast with the other models that we have had in before. And through this process, we're able to eventually select an optimal model based on our selections. So with an evaluated model, we will be able to then receive these kinds of insights from Azure. In this case, receiving topics such as an ROC curve, which is essentially a relationship between the clinical sensitivity and specificity, and afterwards a precision recall curve, which is essentially showing us a relationship between the positive predictive value as well as the specificity of the data, essentially, and afterwards also the lift curve, which allows us to be able to understand the relationship between the positive rate and the number of true positives found. These are able to let us keep track of how our data is doing, essentially, accordingly to essentially based on our current model. For example, in the ROC curve, we can judge based on the data and judge accordingly. Like, for example, if we get like more than a 0.9 as a score, we would basically get an outstanding score for that. If we instead get a range between 0.8 or to 0.9, it'd be excellent. And lower than that would be essentially acceptable and would not be accepted. So essentially, we can judge based on these particular insights. And this is another continuation of evaluating the model. We can then be able to receive a visualization based on the accuracy and precision of the model. And essentially, we can basically measure a threshold. We can adjust the threshold accordingly as to filter the particular data, and basically be able to see where our classifiers have led us into. And in this particular scenario, we can basically move the threshold forwards and backwards to be able to reach an optimal evaluation model that we want to be able to receive. And essentially, what we want to do here is to be able to bolster our accuracy and precision. In this particular instance, for example, if we increase the threshold to up to 0.7, we're able to basically see a better accuracy. But if we keep it, if we instead exceed that, we'll see that the accuracy will slowly go down. So this is just an example of how we choose to evaluate the particular model that we receive. And we also have the option to be able to connect Power BI with Azure Data directly as well. And this is an example of this particular connection. So we're able to essentially connect this through the Power BI interface. We're able to hover over to using Azure as the place to get data from, and navigate to the blob storage that we've already indicated for storing the machine learning data. And we're able to navigate based on this to find the data that we've received. And here comes the Power BI part. So we're able to then visualize the scored data accordingly. And we're able to obtain a lot of possible interesting insights based on this. For example, we're able to generate insights based on the scored data, and basically do interesting things such as generating more averaging based on the particular data that we've received based on the scored data that has already been inputted into the machine learning algorithm and put out, and essentially use this data to be able to better indicate probabilities based on the scoring of what we've achieved within the machine learning model. And this is just another. This is one of the ultimate goals of the machine learning model that we wanted. For example, we're able to finally be able to essentially predict the product engagement, essentially, and focusing on the currently subscribed user based on if they're currently subscribed or not. And essentially, in this particular instance, we'll be able to predict the product engagement if they are if they're currently subscribed users or if they're not currently subscribed. This essentially helps us to be able to better gauge how we're currently performing in terms of how users are engaging with products, and have we managed to convince enough users to be able to engage with our products if they're subscribed, or can we still improve based on the current users that are not yet subscribed, and basically how can we increase the percentage of currently subscribed users if they're currently already using the product. And that's something that we want to look into. And we can also look into, as part of the data, the cities that are currently subscribed, and basically generate more visualizations based on the cities that we select to be able to look more into the particular performance of each city and how the product engagement is doing in each city. So some core KPIs that we may need to monitor as part of this include the deployment time, customer engagement, and leads generated. And essentially, within deployment time, we want to be able to monitor this because we want to be able to better gauge how we're performing in terms of downtime that we have in terms of serving our customers, for example, for our services. Especially since we want to be able to implement many algorithms, such as machine learning and related algorithms. So we want to be able to monitor this. And essentially, which is the whole customer's engagement, which was a huge part of this presentation, was essentially all about how we want to be able to measure how customers are engaging with our products and how we can improve our services to them and how we can encourage more customer engagement based on our services. Can we generate better analytics? Can we provide them with more reason of being able to use services? And how can we convince more stakeholders in our company to be able to adopt new approaches and convince them that if you still need to convince them, for example, that machine learning algorithms really do the trick for generating better insights, that it is a great move to take for the company. Because after all, being able to utilize Azure uses a bit of expenditure as well, especially since some features, including machine learning features, requires some premium subscription as well. And that's something to look into as part of the experimentation into Azure. And leads generated. Of course, we want to be able to monitor if we have managed to generate leads based on our past performances. After our past engagement and after our analytics, have we managed to generate better leads? Have we managed to pick up on more interesting insights? This are stuff that we want to be able to monitor over the long term. And it's a process of iterative development, as I mentioned before. When we talk about being able to monitor on Azure as well as on Power BI, we have to keep monitoring the service that we use essentially. And these also, as part of this, for example, are the cores that we use, the total cores that we use as part of our machine learning algorithms. We want to be able to keep our algorithms running efficiently and our process running efficiently, continue the automation from Azure to Power BI. And part of this is basically using Azure's analytics and being able to monitor metrics, just total cores, the network performance, network bandwidth, and there are much more analytics that we can monitor essentially. And as part of the automation process, we need to be able to keep an eye on this to be able to ensure that we're utilizing our services efficiently. And of course, more monitoring as well. So these are some insights that were also visualized on Power BI. So these are not interesting to customers per se, but they are definitely more interesting to the development team and stakeholders. Being able to compare and contrast two particular machine learning models and how their accuracy and true positive measurements has increased or decreased is very important to us. In particular, we can see in the second graph, for example, that in true positives graph, that in the second model, the true positives have risen as in contrast to the first model. And in that case, we would be able to adopt the first model, the second model instead accordingly. But of course, that is still considering other particular models as well, such as we then have to consider as well the graph, the third graph, for example, which is the recall graph. Is the second model currently performing better than the first in terms of recall? And we could see in this particular model that it is. So we can have a better case for including the second model for this particular case instance for utilization within the machine learning algorithm. And we can continue using this in future and iterative development before we then adopt a newer algorithm that we can then put into place as part of our attempts in basically creating smarter machine learning models. And of course, creating monitoring under statistics such as F1 and also accuracy, as I mentioned before, is very important. And as we go along, we need to continue planning for continuous development. And essentially, we do this within sprints if you're working in an agile environment. So this is an example of how you plan for continuous development in different sprints. So you could be designing models, you could be testing models in the first sprint, and in sprint 2, for example, you could be testing a different model. Because as I mentioned before, being able to develop models isn't exactly a one-time thing. It's something that you have to keep on improving. And it's not something you keep improving in the short term as well. It's something that you need to try out for a period of time before then trying out to do the same kind of task with a different model on a different period. So we want to be able to see how different models perform in different periods. So in this case, we may try a different model in sprint 2 and then do a review of the different models. As I mentioned, for example, in this particular slide, comparing and contrasting how they have performed, and essentially then finalizing the models. For example, it could be on sprint 2 as well, or it could be on doing it on sprint 3. And essentially, we want to be able to then make a decision based on the most optimal model that we can use, essentially, to be able to generate better insights based on Power BI. And of course, we can always utilize tools to accompany deployment, such as Slack or Teams. And if you're not familiar yet, essentially you can use Slack and Teams to update you from Azure's insights, essentially. In particular, when I say about updating on insights, this is in regards to updating on progress in regards to your current machine learning deployment. As machine learning as one of the things that sends you notifications on Azure, the Azure platform, you will definitely receive notifications in regards to whether your pipeline has failed or whether it succeeded, and you're able to directly direct it to Teams or Slack instead. Essentially, you're able to use this to be able to monitor your deployments and check on your pipeline's activity. And basically, with this, create smart deployments. You want to be able to be notified if your automation fails or if your script fails. So essentially, it's something that I definitely recommend to also implement if you have not implemented it yet as part of the communication within teams and as part of the teams that are already currently present in your current company. And of course, briefly mentioning security configurations as well, it's always important to make sure that you monitor security configurations based on the best practices that Azure provides, such as in regards to restricting unauthorized network access and enabling encryption and REST. Essentially, being able to ensure that your models are secure and your data that you are already using within those models are secure. Because they will be data at rest, essentially, until you choose to use them at within Power BI. So it's also important to be able to monitor it and briefly mention it. And of course, when you work as a team on ML models, it's important to remember common things such as principle of least privilege, utilizing conditional access when you need to, and using endpoints between VPNs for preventing breaches within your particular system. And of course, this is another example of inviting users to be able to register directly for the lab as part of the restricting access to who can use your lab. And these are just examples of resolving two common issues in data. These two issues are overfitting and missing values. And briefly mentioning them, regularization and hyperparameter optimization are essentially method to be able to solve overfitting, and performing feature selection is another method. For missing values, as I demonstrated in the previous few slides as well, cleaning data, replacing null values with 0 is always a potential fix, or replacing missing values with a mean, median, or estimate, although it is a lesser recommended action for me. At least for me, I prefer to replace null values with 0 as it makes the data more accurate compared to if we assume that all missing values are within the mean, median, or the estimate. And what we got out of it, essentially, we were able to present findings with more confidence, continue our innovation management of data, understand better on how we were able to manage our services, and make more conclusive decisions. And just a bit of talk on the future of machine learning in Azure and Power BI. Essentially, we want to be able to, one of the things that will definitely come up is in regards to responsible machine learning, which is definitely a topic that will be brought up much more in the future. Essentially, it's all about being able to understand, protect, and control your data, which is very important this time, especially during the age of COVID-19, because one of the facts about this is, according to Northern LifeLock, 1 of 6 Australians apparently respondents in a survey from Northern LifeLock said they experienced a cybercrime during COVID-19, which is terribly alarming. And it is a trend. During these times, it is very important to be able to secure more cloud architecture, because as more people move towards the cloud, the number of cybercrime will definitely also improve as well, especially in this work from home architecture. Of course, after that, moving on to having more open data sets to work with, essentially encouraging more people to be able to contribute more data sets in the open source community, being able to utilize ready-to-use analytics, being able to potentially provide more models for usage within the community, and of course, finally, eventually create smarter learning based on our particular models based on that. And we're able to present better findings and essentially think smarter based on all this. If we're able to basically promote better analytics and essentially work with responsible machine learning, we'll surely be able to create a better system for our company and for the open source community, if we choose to contribute to the open source community, of course. And to wrap up, it's not hard to start crafting and using your own first ML model. I recommend to check over to machine learning in Azure if you have not yet. They have a couple of templates there to try out and experiment with. Make smart business decisions based on the data that you have already performed learning on. And finally, smart decisions equals happier clients, as we have experienced before. We want to be able to make our stakeholders and clients realize that we take data seriously and we want to be able to create the best out of it. And that is all for me. Thank you. And I will now open time for questions.
Great job, Renaldi. We wait a few minutes if question come.
Sounds good. Thanks, Gaetano.
Okay, there are no questions. Thanks to all the sponsors for having contribute to the realization of this event. And thank you, Renaldi, for your availability.
Thank you as well, Gaetano. And thank you for the conference as well for having me.
Bye.
Bye.